Hi, I'm Frank van Nuwet, Chief Architect with GoldenOre, Oracle Gold Partner. I'm here today to talk with you about Oracle Stream Analytics. All data originates in a flash, whether it is from the Internet of Things, web, clicks, transactions, or mobile applications. 90% of all data originated is only from the last year or two, and the pace of the speed of generation of data is stepping up, and we collect more and more data. But traditional analytics is done much later. But why? We want to analyze immediately. We want to analyze on simulated and live data feeds to determine event patterns, correlation, aggregation, and filtering. Oracle Stream Analytics, or short OSA, is a graphical tool that provides business insight into fast data. OSA gives us a web-based platform for exploring, analysis, and manipulating streaming data sources in real time. These sources can include REST, GMS queues, but as well as Kafka. The inclusion of Kafka in OSA helped OSA to step up into the big data game. It is a completely new integration method to work with new build data pipelines that use this as a backbone technology. Previously known as Oracle Stream Explorer, this is part of the SOA component of Fusion middleware. Its big data credentials include support for Kafka as source, but also as a target, as well as the option to execute across multiple nodes for scaling performance and capacity using Spark. When do we use OSA? When we want to build complex event processing applications, pattern matching and detection, when we want to filter and aggregate streaming data, when we have sliding windows, time windows, row windows, value windows, or windows that are time-based, like a day, this hour, a minute, etc. But also geospatial analytics. If we want to analyze where a certain car is at a certain moment, or we want to geofence things, when we want to apply business rules, want to use machine learning, event scoring, and predictions. Visualizing streams and build operational dashboards to help reducing overhead costs, to respond to failing hardware, in example. When we want to run ad hoc queries on results and don't want to wait for effort to have a result, but just be able to ask our data at this moment and get an answer. Helping us in predicting and forecasting the future values based on historical data and PMML models. A few areas of application could be, in example, transportation. We could monitor airlines' operational events to eliminate flight delays. We could use vehicle telematics to reduce fuel costs by monitoring every single sensor in the car and acting on it. But we can also use it in other sectors like retail, for customer experience, in example. Let's say I'm a customer walking up the street, closing in on a certain shop. I get a notification on my cell phone seeing a special offer which interests me a lot. I'm in front of the store, get in and have a look. This is a perfect way to have proximity-based marketing and provide personalized offers. We don't want to have this message delivered to the customer when the customer already passed our shop. That would not work. To respond quickly on such data, we can use those data streams and Oracle Stream Analytics. But also areas as banking for immediate action on payment processing, or telecommunications to have location-based offers, or intelligent network management to drive new service at a lower cost. Healthcare. Imagine a smart bed where a patient is laying in his bed and gets really ill. The sensors detect a differentiation in his body activity and notify, in example, the doctor. Why the doctor can interfere already at a point where maybe his health didn't decline as much as when things already showed visually. In manufacturing, when we can do real-time corrective action for reducing maintenance costs and risks of outages. Or, in example, in IT, to prevent power grid restarts. How does this work? Internet of Things, millions and millions of applications which everybody uses on their devices, mobile phones, laptops, computers, TVs, and of course, real-time transactions created in our standard databases. We all can collect this, by example, using GoldenGate to feed to Oracle Event or Enterprise Kafka. Those streams we can use together with machine learning or with contextual information to complete the data which we are using in our analytics. This information we can use to output to our real-time BI and data lakes, to execute to our BPM workflows, and to have operational dashboards for real-time insight of our data streams. We can use Oracle GoldenGate, as I just mentioned before, to collect from our standard databases the transactions without any real cost on the source side. Feed this to Kafka, connect Oracle Stream Analytics to Kafka, and have a real-time flow to have analysis on our data as it happens at this very moment, without having to go through the pain of having to commit data to a data warehouse, waiting until everything loads and work with it. Geospatial pattern detection can be used to analyze streams containing geolocation data and determine how events relate to predefined geofences in maps, making it an ideal tool to, an example, monitor buses in cities. The deployment modes of Oracle Stream Analytics are, as very many Oracle products, all cloud, which gives us access from everywhere where we want it to be. Hybrid solution where we have on-premises and in the cloud, and of course on-premise if we don't want to use a cloud solution. Making it a solution which can be used everywhere in every enterprise. Okay, so let's go to the fun part and have our sign-in window. We log in to the Stream Analytics window. The first example I show you is a very big data streaming example, which you will see in a lot of examples. It's called Twitter. Twitter is an event-built data streaming, which is even built as a stream source into OSA. All resources are linked under the catalog link. Some of these are stream definitions of sources of data as Kafka, GMS, or dummy data. We can use connections, servers, where we have streams defined. Explorations. This is the front end for seeing the content of streams in real time, as well as applying light transformations. Targets is the destination for transformed streams. If we go to dev.twitter.com, we can get ourselves some credentials to work as a developer. Let's use it here and create our connection to our Twitter stream so that we can filter on some hashtags or users and have some example going on. So here I create a connection in OSA. I provide the data, and now we have an entry in our catalog. For the Twitter connection, from which we can create a stream, we are going to include some hashtags. Let's take some very popular items like Brexit, Trump, and Clinton as hashtags where we want to filter on. This was a very good example during the elections in the USA. Now the stream is created successfully, and we are prompted to create an exploration. Explorations can have multiple stream sources and be used to transform the contents, which we'll see later. For now, after clicking Create, we get our exploration window, which shows the content of our stream real time. You see here our Twitter feed live streaming the data into the dashboard. We can also use stream analytics to create lookups in the dashboard as they stream. So we don't have to wait before our data is committed to some data warehouse. We also can do pattern detection. We can create patterns on predefined values and use this to identify certain messages, certain events in our stream. But also we can daisy chain. This is a very powerful mechanism. Once an exploration is published in OSA, we can use this to combine it with other streams, with other inputs. We can apply transformations in there and use this output as an input on another exploration. This daisy chaining makes it very powerful to have a look at the data, being able to transform, have different overviews, to do predictions. And with this data, we can, in example, have the live feed and look at our diagrams below, seeing the data visualizing in different ways. All this, the possibility of having real-time insight into the data streams, real-time reporting, and a very fast ad hoc querying makes Oracle Stream Analytics a great product.